Hi, welcome to 2.7 inverse functions. In this video, we're going to learn what an inverse function is, how to find one algebraically, and also graphically as well too. So first off, what is an inverse function? Well, it's a function that reverses the process of another function. Okay, you can think of like undoing. So just like in Microsoft Word, if you make a mistake, you can hit the undo button and it will reverses all the processes that were made. So that's what an inverse function does. Another example could be like getting a ketchup stain on your shirt and applying some bleach would be like doing the inverse of it because it'll remove the stain like it never happened. Okay, we've all probably experienced something like this at one point in our life. So the action would be getting ketchup on the shirt. The inverse would be using bleach to remove it like it never happened. So inverse functions can always reverse a process. So if we look at mapping diagrams, if you remember earlier in the year, we talked about how a mapping diagram can take a set X and map it over to a set Y in the domain, or sorry, from the domain to the range. So we can see how 1 maps to 6, 2 to 2, 3 to 4, 4 to 8, and 5 to 10. Well, an inverse function does the same thing, except it's going to take that set Y and it's going to map it back to X. So it reverses the process. You can see how we go from Y back to X. If you think about like function machines, so if we had let's say the x squared function and 3 goes into that function and out comes 9, well, the inverse symbol, so this here means inverse, okay? It's not an exponent. Okay, when you see that -1 with f or with y, it means it's an inverse function. Okay, it's not an exponent. So when 9 goes into the inverse function, 9 is going to be square rooted. That will reverse the square process, and you would get 3 on the way out. Okay, let's see it with some other numbers. So if we plug in 5, 5 squared is 25. Well, 25 in the inverse function, it'll get square rooted and it'll come out as 5. So you're always going to go back to the number that you started with. Okay, and lastly, 11 turns into 121. Plug 121 in and it reverses it, and out comes 11. So that's what inverse functions do. If we were to take a look at ordered pairs, we could have a table, x, y. So here we got negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. Kind of looks like a parabola, x squared. Well, the inverse of this function will actually take the y values and bring them back to x. So basically x and y would just switch. So we get 1, negative 1, 0, 0, 1, 1, 4, 2, and 9, 3. So you can see the x and y values are switched. So graphically, the x and y values of a point are switched. So we could see the 0.47, that's right here. The inverse of that would be 7, 4. And same with negative 5, 3, the inverse will become 3, negative 5. So the x and y values just switch. Let's look at another one. So you got a table there. We can see the points. Okay, there's about 6 points there. I've only kind of shown 4 of them in the table, but you can see like 0, 1, the y-intercept, and 1, 2, 2, 4, and 4, 8. Those points exist. Well, the inverse will take the y values and bring them back to x, which basically means the x and y switch. Okay, so here's our inverse in blue. Okay, so there's the inverse points. So we can see 0, 1 became 1, 0, and 1, 2 became 2, 1, so on and so on. Now, I asked here, is there a line of reflection? So is there potentially a line on this graph so that if I folded the paper along the line, the green points could end up on the blue points? Okay, so far we've looked at the x-axis as a line of reflection. We've looked at the y-axis as a line of reflection. We've even sometimes have done both. I don't think any of those combinations are going to work though. So if you want to take a moment and pause the video and think about what line you could reflect the green points on to get the blue points, go ahead. So maybe you might have guessed it, but that line is actually the line y equals x. It cuts it right through the origin. If I fold the piece of paper on that red line, the green points would land exactly on the blue points. Also notice these distances are equal, right? They're equidistant, okay, between all of them. So basically, we can say the graph of a function and its inverse are mirror images about the line y equals x. Okay, there we got a fancy y equals x. All right. So how can we do this algebraically? Well, if we know that our ordered pairs, if we know that x and y switches, well, algebraically, we can do the same thing. We can first switch x and y, okay, in our equation, just completely switch them. The next thing you have to do is you have to isolate for y. So you want to get y by itself again. So notice to get y by itself, we have to reverse all those operations on the right side. First, we'll have to add 12 to both sides. Okay, so we'll add 12 to both sides. When you do that, that cancels, and we add 12 to this side. Okay, giving us this line over here. And then to get y by itself, the next thing I got to do is I got to divide 6 by both sides. Okay, so that's how we get this line here. Next, just simplify. So you can write it as 1/6 of x, or even x over 6 is fine. And 12 over 6 is just 2. So the only thing you don't want to forget to do is after you've isolated y is to write that little -1 symbol on top to show that it's the inverse. Okay, and that's it. So this function here that I just put the red box around, that's the inverse of this function up here. Okay, so if you're not sure if it's the inverse, we'll just do a test. What happens if x is 1? What's the y value? Well, 6 minus 12 is -6. Okay, so this point satisfies this equation. Well, let's see if we can reverse it. Can we put -6 into this function here? Well, if we put -6 in for x, -6 over 6 is -1. -1 plus 2 is +1. So yes, it works. It actually reverses the point. Okay, let's try one more. So there's the function. If you want to go ahead and try to find the inverse, you can pause the video. Your first step will be to switch x and y, and then solve for y. Okay, so why don't you go ahead and try it. Okay, welcome back. So switch x and y, that's our first step. Okay, so now y becomes squared. And now the next thing is to isolate for y. So we got to get y by itself. So we're going to reverse all the processes that are happening to y right now. So we're going to have to subtract 2 first from both sides. So this might happen quickly here. Okay, so we're going to solve for y. So first thing is to subtract 2 from both sides. Okay, so that's how we go from here to here. And then we want to divide both sides by 3. That's how we go from here to here. Okay, and now this equation is y squared. Well, we want to know just what y is. We want y by itself. So how do you reverse a square? Well, you square root both sides. That's how we go from here to here. Okay? Don't forget that little -1 symbol because this is now the inverse function. Okay? It's the inverse function because we're not putting that plus or minus in front of it, okay? If we're including the positive and negative values of the square roots, then we won't have a function anymore. So some of the questions in the textbook will want you to put the plus or minus, some of them won't. So just be a little bit careful about that, and we'll talk more on that later. Okay, that's our first intro video for inverse functions. I will see you in the next one.